Flow demands specify flows entering or leaving the system. External outflow leaving the system and external inflow entering the system are both specified at a node. In Model 1, flow from a source tank to a node with a specified outflow demand is modelled. To specify the outflow demand, click on the node, and then in the node pane, next to the demands out parameter, click the Edit button. This opens up the Set Flow Demands window where you can specify the demand out. Alternatively, you can select the Add Demand Flow button from the toolbar and then click on the node that you want to add the demand to. There is a third way to edit a demand out value, and that is to click on the end of the demand out arrow, and then you will see the Set Flow Demands dialog. In Model 2, flow from a node with an inflow demand to a receiving tank is modelled. Again, the inflow demand is set by either clicking the node and then clicking Edit in the node pane next to the demands in, or again we could use the toolbar button. Demand flow at a node between tanks is specified in the same way. Model 3 shows flow between two tanks with a specified outflow or takeoff at the node in between the tanks, and this demand out is specified as before either via the node pane or via the toolbar button. Demands in and demands out are additive. Model 4 shows a node where there's a demand in and an equal demand out at the same node. In this case, those demands are redundant. I am now going to solve these systems and view the results drawing. In the model at the top left of the screen, we have a pipe from a tank to an end node with the demand out specified, and this demand out is the outflow from the node into some other part of the system that we haven't modelled. Pipeflow Expert has calculated the pressure at this node, given that the flow in pipe 1 is 100 US gallons per minute. The reason pipe 1 has a flow of 100 US gallons per minute is because it's the only pipe that connects to the node with the demand out set, and the demand out is set to 100 US gallons per minute. In the model in the bottom left of the screen, we have a start node with a demand in specified of 100 US gallons per minute, and this is the flow into the node from some other unspecified part of the system. We have a pipe that connects the node to an end tank with various properties set for surface pressure, liquid level, elevation, and Pipeflow Expert has calculated the pressure at the start node that is required to achieve the flow in the pipe to that tank. Again, because we only have one pipe connected to that node that's got the demand in specified, the demand in is effectively setting the flow rate in that pipe. In the diagram at the top right of the screen, we have a node in between two tanks with a demand out specified. In this case, Pipeflow Expert has calculated the total flow, which we can see in pipe 3, which leads to the node in the middle. The demand out at that node is 30 US gallons per minute, and again that's taken off and is feeding into some other part of the system that we haven't modelled. And we can see the remaining flow in pipe 4 has been calculated. The sum of the flow in this pipe and the demand out equals the total flow that we can see in pipe 3. And Pipeflow Expert has also calculated the pressure that will exist at that node in between the tanks. The final model in the bottom right of the screen is the one where the demand in is equal to the demand out, and so these flow demands have no net effect.